Hey guys, so last time we started 5.2 triangle practice problems. We did pages 1 and 2, and today we're going to look at pages 3 and 4. So let's start off with problem number 14. What value of x makes triangle STW similar to triangle ABC? Well, I see a similarity statement, so I'm going to stack them. And let me get my drawing tool. S, T, W goes over A, B, C. Okay, now I can see what matches up. So S, T matches A, B. All right, that has 2 over 8. Now it's important that we pick the one that has 2 numbers so that we have some sort of scale factor. And we can reduce this to 1/4 and use that, or we can just set up a proportion of sides. And it does not matter which other side pair you use, as long as they match. So I'm going to choose TW. That's right here. So TW is going to go on top because it's from my top triangle. 3x minus 10 over, well, what matches TW? BC. And BC is here, so that is 2x plus 8. All right, let's cross multiply to solve this proportion. 8 times 3x minus 10. Remember that we're going to put 3x minus 10 in parentheses next to the 8 so that we remember to distribute the 8 to both. And that is equal to 2 times 2x plus 8. Okay, I'm going to draw my river. And now we're going to use the distributive property to distribute to both sides. 8 distributes to the 3 and to the negative 10. So 8 times 3x is 24x. Minus 8 times 10 is 80. All right, equals, distribute the 2 to the 2x and to the 8. 2 times 2x is 4x. Plus 2 times 8 is 16. Now I'm going to subtract 4x from both sides so that I can get all my x's together. I don't know if we've mentioned that it is the subtraction property of equality that allows you to do that. Basically, that says that if you have 2 expressions that are equal to each other, if you subtract the same thing from both sides, the expressions will remain equal. All right. So now 24 minus 4 is 20x minus 80 equals, those cross out, 16. Next, to get x by itself, I'm going to add 80 to both sides. crosses out, and so 20x equals 16 plus 80, which is 96. Let's divide both sides by 20. All right, and I'm going to grab my calculator to do that. 96 divided by 20. I got a decimal. Does that mean I'm wrong? No. Nope, decimals are perfectly fine as answers. X is equal to 4.8. Now, if you're the type who says, I don't like decimals, especially if it's a repeating decimal, which this one is not, I want a more exact answer, that is totally fine. If you look at 96 and 20, both are divisible by 4. And so what we can do is we can just write the answer as an improper fraction, where x is equal to 24 over 5. If you want to write it as a mixed number, 5 goes into 24 4 times. And so you get 4. And we have 4 left over 5 for an answer of 4 4/5. Any one of these is an acceptable answer to what is the value of x. All right. Let's take a look at 15. I've already marked on 15 that we have a reflexive angle in our little triangle here and our big triangle here. So what I need to do is figure out how to solve for x and y. And a big part here is which one do I solve for first? Well, if I look, I've got these congruence marks, which means that solving for y is going to be really simple for me. I just come here and say, all right, well, those congruence marks mean that those are equal. So 3 times y plus 2 equals 12. Draw my river, and I'm going to distribute that 3. So 3 times y is 3y plus 3 times 2 is 6 equals 12. I'm going to subtract 6 from both sides using that subtraction property of equality. And I get 3y, that crosses out, equals 12 minus 6, which is 6. Finally, we'll divide by 3, division property of equality. And y is equal to 6 divided by 3, which is 2. Now, with that information, I now know that this here is actually 12, which means that the entire side length is 12 plus 12, which is 24. And that is going to help me solve for x. Here's why. We have this shared angle, or this reflexive angle here. And you see that we have a side that's marked congruent here and here. So whatever number this is the same, meaning that the entire thing will be double this. Same here, 12 and double is 24, which means that those sides are in proportion. So I have two sets of proportional sides, and a reflexive angle between them, these triangles are similar by side angle side. And that lets me set up a proportion to solve for these. Okay, so I can say 12 over the whole thing is 24 equals 16 is on the small one over, and x plus 5 is the big one. And now I'll cross multiply to solve. Let me show you a little trick. 12 and 24, it's a kind of big numbers. It would be a lot easier if I could reduce them, which I can. 12 and 24 both divide by 12, and I get 1/2. So I can just come over here and say that 1/2 equals 16 over x plus 5. So now 1 times x plus 5 is x plus 5, because 1 times anything is itself. 16 times 2 is 32. So all that's left for me to do now is subtract 5 from both sides. And I find that x is equal to 32 minus 5, which is 27. Okay, let's do a little more work with similar triangles. If we go to problem 16, we're given that AE is 15 and EC is 6. Now, hopefully you've been watching with me long enough to know that this big triangle, I need to add these numbers together to find the length of the big triangle side. 15 plus 6 is 21. And then AD is 10 and DB is 4. So this long side of the bigger triangle is 10 plus 4, or 14. Now, this says complete the, that should not say congruence. And hopefully on your sheet it doesn't. I've let them know that needs to be changed. So we're going to be completing the similarity statement. All right, so I need to figure out, first of all, if these are similar at all, and if they are, what matches up. Let's look. I'm going to put the small triangle on top and the large one on bottom. And when you're doing this, look to match small over small and large over large. So here, of the two sides I have, 10 is smaller over, and for the large triangle of the sides I have, 14 is smaller. Well, both of those divide by 2, so I get 5 over 7. That's looking good. Now, we're going to check and see if I get the same reduced fraction from the other set of sides. The small side is 15, and the large side is 21. I can't divide by 2, but I can divide by 3. 15 divided by 3 is 5, and 21 divided by 3 is 7. So, as you can see, they are similar because the sides are in proportion, and we have our reflexive or shared angle right here at angle A. So, because A is a shared angle, I know that A is going to match A. So traveling from A to D, I traveled the short side, and what matched that was 14. So I'm traveling A to B, and AE matched AC, which means that E matches C. Now we need to put the theorem that tells us that two triangles are similar if they have a congruent angle, which a reflexive or shared angle is, that is between two sides that are in proportion. We absolutely have that here, side, angle, side. So triangle ADE is similar to triangle ABC by side, angle, side. Let's move on. 17. If AB is parallel to CD, okay, parallel, which of the following statements is true? All right, I'm going to stop right there and I'm going to mark my vertical angles because that's what we do. We mark what we know. I have no reflexive or shared side. No sides are marked here. So anything referring to sides cannot be true, which means that A cannot be true and B cannot be true, because parallel sides does not mean congruent sides. Okay. Now, you see your parallel lines here make a Z shape. Y'all see that? And what you have are parallel lines that are cut by a transversal, and in the corners, you are forming alternate interior angles. And we know that alternate interior angles are congruent. So these angles here, angle C and angle B, are alternate interior angles. Now, could I have chosen A and D? Absolutely, I could have chosen A and D. You're just looking for that Z shape to show you that you have those alternate interior angles when lines are parallel. So it is angle, angle. So now we need to see what matches up. Well, they start with CDE. So I'm going to write CDE. If I look at C, I've marked it congruent to B. I've also marked E congruent to itself. Vertical angles, also reflexivity. And that leaves D and A as congruent. So I'm looking for BAE being similar to CDE by angle, angle. Okay, 18. Which side lengths would not represent the sides of a right triangle? For this, I need to check A squared plus B squared equals C squared for every single one of these. Now remember that C must be your largest side. All right, so here, I'm going to do A squared plus B squared. So on my calculator, I'm going to do 4.8 squared plus 28.6 squared, and I get 841. Now I'm going to do C squared. I get 841. Now those are equal. So A is a right triangle, but I am not looking for one. I'm looking for something that's not a right triangle. So A is not my answer. Next, A squared plus B squared, 9 squared plus 12 squared is 225. 15 squared is C squared. That's also 225. So for B, A squared plus B squared does equal C squared. So that is not what I'm looking for. A squared plus B squared, I just did 9 squared plus 12 squared, that's 225, equals, and 17 squared would be my C squared here, and that's 289. Are those equal? No, they are not. So C is not a right triangle. Now, just for fun, let's do D just to double check ourselves, make sure we're right. I've got 10 squared plus 49.5 squared, and I get 2,550.25. Does that equal 50.5 squared? 50.5 squared, yes, I get the same thing. 2,550.25. So that's a right triangle, and I was correct that C is the one I want. Good job. Let's go to page 4. Page 4, we're going to find the length of the hypotenuse, and we're going to round it to the nearest tenth. Now, here is where we're going to need to use trigonometry. And we remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And we're going to want to label our triangle. So the first thing you do is locate your right angle. And across from your right angle is your hypotenuse. Then locate your given angle, or wherever your angle is indicated, and that's your theta. And opposite your theta is your opposite side. Next to your theta, but not your hypotenuse, is your adjacent side. So here, what I have is an adjacent side and an angle, and I'm looking for the hypotenuse. So I'm going to put my X here. Well, I'm using A and H, which means I'm going with cosine. So I've got cos 16 equals A, which is 35, over H, which is X. Now, what I'm going to do is actually put this over 1 and cross multiply. So cos (16) times X equals 1 times 35, which is 35. All right, now I'm going to divide by cos 16 to get X by itself. And that's going to cross out. So X is equal to 35 over cos 16. So I'm going to grab my calculator and I'm going to hit my mode button to make sure that I'm in degrees. It's going to be the third line down. You want degree highlighted, not radians. Then I'll simply type in 35 divided cos 16. Now, this is different if you're using your phone. If you have an Android like me, what you'll do is you'll open up your calculator app and it's already in degree. You'll see that it says RAD in capital letters. If you click that, you're putting your calculator into radians. Don't do that, stay in degree. And then what you'll do is you'll do 35 divided by cos 16. If you have an Apple in your calculator, I believe what you have to do is type in 16 and then hit cos. Write whatever number that is down. Let me just check and see what it is. You'll get 0.96126, and then you'll just type into your calculator on your phone 35 divided by 0.96126. I think that's how you have to do that on an iPhone, but I don't have one, so you can always check. All right, I want to round to the nearest tenth. That's 1 decimal place, and I find that x is equal to 36.4. Now, do not put degrees on this. I'm not looking for an angle. I am looking for the length of the hypotenuse. All right, number 20. I want to solve for x. Aha, I know this one. I have a 45, 45, 90, and I know that because the legs of my triangle are congruent, which means that this is 45 degrees and this is 45 degrees. Now, in a 45, 45, 90 triangle, your side ratios are x, and x times the square root of 2, where this is your right angle and these are your 45-degree angles. So that means x, that means that x times the square root of 2 is equal to 20. So to solve for x, I'm going to divide by the square root of 2. Okay, that crosses out, but I'm really not supposed to have that. All right, I'm not supposed to have a radical on the bottom of a fraction. So what I do, because I know that the opposite of a square root is being squared, and I know that squaring something is multiplying it by itself, I'm going to multiply both the top and the bottom by the square root of 2. And the reason why I can do that is because any number divided by itself is equal to 1. And if I'm multiplying my fraction by 1, I'm not actually changing its value. So now I have 20 times the square root of 2 over multiplying by itself crosses out the square root and just leaves 2 behind. All right, now that's not one of my answers, but that's because 20 can divide by 2. 20 divided by 2 is 10. So my overall answer is 10 times the square root of 2, which you will see is option D. Okay, 21. Let's solve for x. Well, this one, they've given us 20 as the side. I know that these are the same and that this is 45 because it's a 45, 45, 90 triangle. The reason I know that is because triangle angles always have to add up to 180. This means 90. This is 45. 180 minus 90 minus 45 is 45. That's what's left over. All right. So I know that if this is 20, this is 20. And if this is x and this is x, this must be x times the square root of 2. So it is simply going to be 20 times the square root of 2. We are allowed to multiply by radicals. We don't have to change anything. We can just simply circle the answer. All right, we got 2 more. You guys are doing a great job. Number 22. Let's solve for x. All right, again, here we are using trigonometry. Here is my theta, and I am going over here to my opposite side. From my right angle, I go to my hypotenuse. And then this is my adjacent side because it is adjacent to theta, but is not the hypotenuse. So I am using O and A. O and A is tangent. So tan theta, which is my x apparently, is equal to O over A, which is 8. Okay, so here's the problem. I can't type tan x and set it equal to 15 over 8 in any of my calculators. So here's what I have to do. I have to use the inverse. And what the inverse will do is it's going to swap the x and the y. Basically, in a trigonometric function, whatever value this is your x value, and this is your y value. So we're going to swap them. And the way we'll do that is by using the inverse function, which is represented as tan -1. Do not just hit the -1 button on your calculator. I'll tell you what to do in a second. But that's going to switch what's inside the parentheses with what is on the other side of the equal sign. Got a little ahead of myself there. I forgot my equal sign. Okay. All right. Now, if you're on your graphing calculator, you're going to hit the blue button and then the tan button before putting in 15 divided 8 and closing parentheses. Now, if you're on your phone, again, going to your calculator app, you'll see in capital letters INV. You might have to turn it sideways if you're on an iPhone. And when you click that, it's going to change your sine, cosine, and tangent into sine inverse, cos inverse, and tan inverse. So tan inverse, and then just type in the 15 divided by 8. Again, with iPhones, I'm not sure. You might have to do the 15 divided by 8 and then hit the sine in or the tan inverse function. Double check that. If someone could let me know in the comments below, that would be awesome. I can add a little card to say which one it is. All right. So either way, you should get x equal to 61.9 degrees as the measure of your missing angle. All right, last one for today. Using this picture, which could we not use to solve for x? All right, we got to label it, guys. Here is my hypotenuse. Here is my opposite, and here is my adjacent. All right, real quick, we're going to write down again that sine must be opposite over hypotenuse. Cosine must be adjacent over hypotenuse. And tangent must be opposite over adjacent. Now, let's take a look. Tan of 30 is O over A, or 16 over X. That can be used to solve for X. Cos of 30, adjacent over hypotenuse, X over 32. That one works. But now they're talking about 60. Where does that come from? Well, it comes from here. Because all the angles have to add up to 180. And so 180 minus 90 minus 30 is 60. So to use that one, I'm going to relabel my O and A. If I'm going from 60, now this is my O and this is my A. Sine 60, opposite over hypotenuse, X over 32. Good. Tan 60 would be opposite over adjacent, or X over 16. So this is the one that's out of place. Good job, guys. I'll see you next time to continue triangle practice problems, pages 5 and